Sasigal students, let's discuss principle of dimensional homogeneity. This is our lecture in physical world and measurement class 11th physics. Now, students, principle of dimensional homogeneity is basically a consistency test for any equation. Consist Consistency test. Well, if you have a equation, any equation, I'm talking about physics, there are some variables on left hand side, some variables on right hand side. Some variables have different dimensions, means their indices or their exponents or their powers. So principle of dimensional homogeneity says that whatever is the value of MLT, mass, length and time on the left side, on the right side you may be having so many variables, maybe divided by some variables. So totally when you take MLT on the right hand side, they should exactly match. Means the powers of MLT on the left hand side and right hand side should be same. If this is correct, then the given equation passes the consistency test, otherwise not. But students, it's very interesting to see, even if a equation pass the consistency test, the equation may be wrong. How? Just see, if I talk about work done is equal to torque. Let's say I write this equation, right? Now I may also write pressure is equal to stress. In both the equations are wrong because pressure is not stress. The stress can be pressure if the forces are applied perpendicular to the area. But if the forces are at inclined angle, then that don't constitute for pressure. But the MLT of pressure and stress are same. What is that? The MLT of pressure is, force divided by area. So force divided by area, force is MLT minus 2 divided by area is L2, that is ML minus 1 T minus 2. Well, the stress also has the same, you know, indices of MLT on the right hand side, but that doesn't mean the equation is correct. Similarly, work done and torque. Torque is a vector quantity and work done is a scalar quantity. Torque is expressed by cross product and work done is expressed by dot product. So, even if the equation passes the consistency test, the equation may be wrong. But still, principle of dimensional homogeneity, if we know that the equation, you know, equation is there, some given equation is there, maybe one of the indices written is wrong, then principle of dimensional homogeneity can really help us to correct that indices. Or principle of dimensional homogeneity can also help us to derive a formula also, though not complete, but partially. It may not be able to derive the constants, right? Derive the formula. In the present equation, we will take two examples and see how strong and how beautiful mathematics is. It can even derive a formula. If a scientist or a researcher feels that a given variable depends upon one, two, or three variable, it can really, this principle can really help us to tell that what will be the exact formula to 70, 80, 90% extent, because he has to do the experiment, the researcher, to exactly find out what will be the value for the constant, right? For example, principle of dimensional homogeneity can easily tell us the time period of a pendulum is k l by g. It cannot help us to find out the value for k, whereas by other ways we can find that k is actually equal to 2 pi. Okay, fine. So guys, let's go further. And first, we will see how to apply principle of dimensional homogeneity to see the correctness of a formula. Correctness. of a given formula. So students, you can take any example. Let's say you take example. Let's say we say that let's say we say that kinetic energy is equal to, it's given, half m square v square. We know it's wrong, but let's say there's an equation we don't know. So how we can find? Now we know kinetic energy, unit of kinetic energy is a unit of energy, is a unit of work done, right? So what is the unit of work done? Force into distance. So left hand side we will see what is MLT and its related dimensions, means powers of MLT ABC. So in kinetic energy, we know it's work done. So on the right hand side, I can do this. Well, work done is equal to, we know, force into distance. And force is m l t minus 2 into distance is l. So this is m l 2 t minus 2. On the left hand side, I will get ml2 t minus 2. On the right hand side, 1 by 2 doesn't have any constant, any dimensions. So m2, m2 is, m is mass. So m2 means I will get m square, right? And here v is l t minus 1. You know, I can do square of this also. So this will be m square l2 t minus 2. Whereas on the left hand side, it is m l2 t minus 2. So you see the, if you see the unit of this dimensions of length and time are matching, but the dimension of mass are not matching. Here it is 1, here it is 2. So that means this equation is dimensionally incorrect equation. Okay? And then we know that if we remove this square and if you put half mv square, then the square will be removed. It will be dimensionally correct equation. So this is simple, you know that, but even if equation is not known to you, you can apply the same method to find out whether it is dimensionally correct or not. Okay, students? Yes, Jasmine, have you understood?
Yes, sir.
Okay, that's good. So let's say there's another equation. It says the time period of oscillation, uh, time period of oscillating drop of radius r, density rho, and surface tension s, huh, is t is equal to k rho r cube divided by s. Let's say this is a given equation. I want to check whether it is, I want to see the correctness of the relation, right? It is come in board exam also. So how will you say? So you see left hand side is equal to t. So what is the dimensions of t? It is this t. Am I right? Now right hand side is equal to k rho r cube divided by s. Am I right, Jasmine? So I believe that I assume that this k is a dimensionless constant. So I just get rid of this. Now this is density. Density is mass by mass by volume. Mass by volume is ml minus 3, right? And this is r cube. R is radius, so that is l cube, right? Divided by, now this is surface tension. Surface tension, students, if you know, surface tension is equal to force by length. Force by length. So force unit is mlt minus 2 divided by L. So it will be mt minus 2, right? So this will be mt minus 2. Am I right, students? So now what you can do, you can just see. So you see that L minus 3 and L is 3. So this will cancel out, right? Now M will cancel with M also. Am I right? M will come. Oh, sorry. This is the under root over this. Huh? So it will be t. It's t minus 2. Okay, na? So if it is t minus 2, so this is t square and under root. So that is t. So you see the right hand side is also t. Left hand side is also t. I can say this is dimensionally what? Yasmin, correct or incorrect?
Correct.
Wow, very good, very good. It's dimensionally correct equation. So this is how we can see the dimensional correctness of the equation. This we had not done yesterday. So we have done it today, and yesterday we had done something else. So we will just repeat it, but I'll take different sums. Okay. So you see, students, I will be doing this. I'll change this color to give solace to your eyes. Okay. One and two. Let's do one more if time permits. Let's do one more. Okay, students. So we want to derive a formula. So deriving a formula is not so easy, but for scientists, they take years and years to find a formula. So you see that we can take 5 minutes to derive a formula, right? So how do we do it? Okay, so let's take some sum. So students, see this formula. Now we will derive a formula. Now we will derive a formula. So, okay, God forbid nobody gets hit with a bullet, but scientists are really great people. They have even uh, tried to formulate a formula for the depth of the depth to which the bullet will penetrate in a human body if the person is fired. So it is assumed that the depth the depth to which the bullet will enter the body, let's say that is x. So it depends upon coefficient of elasticity. Coefficient of elasticity we can represent it by eta, and then the kinetic energy, and coefficient of elasticity and kinetic energy, obviously not of the body but the bullet. Kinetic energy we can write of the bullet. So by the methods of dimensions, by the method of dimensions, we have been asked to derive a formula. The formula is already there, but we can still derive it also. So students, how to do it? So we believe now x is proportional to one is eta, and coefficient of elasticity, mm, and kinetic energy, so that we can take as k. So students, we don't know by the formula what we mean, that in the formula the dimensions must be specified, or the powers of this coefficient of elasticity and kinetic energy must be specified. In other words, you can say whether x, the depth of cut, linearly depends upon coefficient of elasticity, or it is square of coefficient of elasticity, or under root, or whatever it is. We don't know what are the indices. So we assume that the indices is A. And here kinetic energy, we assume that the power or indices or dimensions is B. Okay. So we can introduce a dimensionless constant K. From 10th standard, whenever you want to get rid of this proportionality, you have to introduce a constant of proportionality. So let's say kx is equal to k. We don't know what is k. This is a limitation of dimensional analysis. We don't know. Leave it. We don't know what is k, so need not give a power to it. So k, coefficient of elasticity raised to power a, and this is kinetic energy raised to power, come on, Arjinder, raised to power b. So now we will be able to find out the value for a and b. So we will get the formula. This will be the formula once we know the value for a and b. Fine. So on the right hand side, students, we should know what are the dimensions of kinetic energy and coefficient of elasticity. So students, do you know coefficient of elasticity is equal to, anybody knows? Anybody knows? Coefficient of elasticity is basically stress divided by strain. So the units of stress is same as pressure. So pressure is force by area, so it will be ml minus 1 t minus 2. We have just derived. ठीक है? And strain doesn't have any constants, doesn't have any units. And some foreign authors write the strain like mm by So you again, the MLT will not exist. All MLT will be 0, 0, 0 for strain, right? Because it is same unit by the same unit. So for stress, force by area, force is MLT minus 2 divided by area L2. So it will be ML minus 1 T minus 2. And for kinetic energy, yes, Jasmine, please tell the MLT of kinetic energy. M, L. Yes, Ishma, tell the MLT of kinetic energy. Kinetic energy, potential energy, work done, any kind of energy, they have same MLT.
ML2 T
ML
minus
to
2.
ML2
T
T minus 2. We should be
T
quick
minus
in answering, huh? Okay. The recording is going on, but I want your contribution to be there in recording also. So it's force into distance now, so it's multiplied by L. Here it is divided by L square. So now we know that. So what we will do, we will take this. Now we will see. We will apply the principle of dimensional homogeneity. What? For an equation to be correct, huh, the dimensions of MLT on left hand side and dimensions of MLT on right hand side should be what? It should be, come on,
same.
same. So, and Jasmine, what is the MLT of X? X is distance. So this is human body. Let's say, this is the person. So the bullet comes, so it enters till here. So this is X. How much it penetrates inside the body. So what will be the MLT of X? It will be L. Am I right or wrong? Length, it's length. Distance, X is distance, is equal to, so L will be equal to, now you need not write the square brackets here. Forget about K. K we assume as dimensionless constant. So instead of coefficient of elasticity, we will write which formula? Here we will write ML. Tell me students, minus 1 T minus 2 raised to power, come on,
A.
A, beautiful, into kinetic energies. Yes, Jasmine. M, see that? See here. This is kinetic energy. M, L,
L2 T
A,
minus 2
raised to power. Kinetic energy.
minus 2
No, 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 no. Minus 2. This whole. This is kinetic energy, na?
B
Yeah, raised to power B. Because we don't know the depth of cut depends upon kinetic energy. How? We don't know whether it is square relation, cubic relation, or linear relation. If it is linear relation, B value of B will be 1, right? See, when I say X is proportional to Y, this is a linear relation. When I say X is proportional to Y square, oh sorry, proportional to Y square. So this is, you say, what is quadratic relation? It will become a quadratic equation once we know the constant of proportionality, right? Okay, so fine. So we will just multiply. So it will be what? M raised to power A into L raised to power. Come on, Jasmine, can you speak? Minus A, then T raised to power. Multiply A with all the powers. Minus 2A, right? Into, I'll be happy, Jasmine, if you speak, or Arjinder. So now multiply B by all the powers of this is just mathematics. Like you do X
M
square, Y, Z.
MB
1 second. Cube will be equal to simply X raised to power 6, Y cube, Z cube. Simple. It's simple thing. So 1 second. So can you just help me to, what will be this? M raised to power B
M
into
raised to power B
L raised to
L
power.
raised to power 2B
Very good. T raised to power.
minus 2B
Oh, beautiful. Really good. So now you apply that. This is base is same, M into M. So it will be M raised to power. The powers will be added. Powers of M will be added. So what it will be, Jasmine?
AB
M, not AB. You see, X raised to power 5 into x raised to power 2 is equal to, is it x raised to power 10? No, it is x raised to power 7. When the base is same, the powers are, yes, Ishma? When the base is same, the
Plus
powers are
Added.
add
added. So it will be A plus B. You got it? So next comes L. Yes, Jasmine, can you tell? Just add these
minus
powers.
A
Yes, very right. Just add these powers.
to B
Minus A plus
to
2B
B
into T raised to power minus
minus
2A
2A
minus 2.
plus
Yeah.
minus
Ah,
2B.
you can write like this plus also. Yeah, you can write like this plus then minus 2B. So that will be same as,
Minus
yeah, it will be same as minus 2B. Now students, what the principle of dimensional homogeneity says, now L can be written as m raised to power what, Arjinder? L is 1, T is this. How can I write left hand side L? So m should be, anyone? 0.
0.
And T should also be 0.
0.
Zero.
Only L should remain, right? So from here, now I will equate corresponding dimensions. So I will get three equations. Yeah, Jasmine, can you help me tell the equations? Equate the dimensions of mass first. So you will get 0 is equal to, see, they should be same now. This on the
Yes,
left hand side and this is the
right hand side.
right. So 0 should be equal to A
A
plus
plus
B.
B.
Very good. Second equation will be, now equate
1
the powers of L. What is the power of L here? 1.
1
So 1 should be equal to,
minus A plus 2B.
perfectly right. And the third equation is,
0 is equals to
yes, minus
minus
2A
2A
minus
minus
2B.
2B.
Okay, please write down, Jasmine, and I'm going to shift to the next page. Then you repeat them. Just write down and repeat them. Yeah. So what are the equations? Tell me again. First was 0 is equal to, please repeat them. Ishma, can you help me? 0 is equal to A plus B. What was the second? 1 is equal to
1 is equal to minus a plus 2b.
minus A plus 2B. And 0 is equal to
Minus 2a minus 2b.
minus 2B. Yes. Jasmine, do you agree? So, so we have three
Yes, sir.
equations. We can easily find out. Now, from this first equation, we know A is equal to minus B from the first equation, right? So we will put in this A is equal to minus B. We will put in this. So minus A will become B plus 2B is equal to 1. So Jasmine, what is the value for B?
1,
1 by, see,
2,
B.
1
No,
by
no,
2.
no, no, not 1 by 2. 2B plus B is 3B. 3B is equal to 1. So B is equal to 1
1
by
over 3.
1 over 3.
3.
When B is equal to 1 over 3, simply I will get A is equal to, A is minus B minus 1 by 3. Am I right? See, A is equal to minus B from here. So put the value for B, A is equal to minus 1 by 3B. Okay. Jasmine, you understood?
Yes, sir.
Very good. So what will be the formula? We had written the formula as the same formula, write down again. Neta A. So x is equal to dimensionless constant, neta raised to power A, then kinetic energy raised to power B. So x, that is depth of cut. Depth of, you can say not cut, but you can say depth of penetration. That's a better word. How much the bullet will penetrate. Penetration in the body would be equal to, x. X is equal to, come on. So it will be neta the power What is the value for A? Come on, students. What is the
minus
value?
1 upon 3.
So it will be minus 1 by 3 into what is kinetic energy? Power
1 by 3.
1 by 3. So I will say x is equal to, I don't know what is constant. This will go down. It will be E k divided by eta cube root. 1 by 3 means cube root. You know that when I write square root, it is x raised to power 1 by 2. When I write like this, then that means it is fifth root of x. X raised to power, anyone can say 1 by 5, right?
5.
If I write here m, this is mth root of x. This is x raised to power 1 by
M.
m. Beautiful. So successfully we have derived the formula for the depth of cut. Am I right? So this is how we do the thing, students. Uh, so you see that now if I say the potential energy, depends upon what? Mass, then acceleration due to gravity and h, right? So we will derive this formula. It's not in the book. I'm just doing it on my own. So potential energy is work done. So first we will write, let potential energy is equal to constant k m raised to power. Come on, students, anyone? A, g raised to power b, h raised to power. Come on,
C.
c. Good. So potential energy, write down the units of potential energy. It's work done. Work done is force into distance. So what it will be? Any student? What will be the MLT of
M.
ml2 t minus
ML2
2.
minus 2.
good? So this will be left hand side. On the right hand side, forget about K. I think this is dimensionless constant. So it will not have any unit. M e raised to power A. G is L T minus 2 acceleration raised to power B. So what will be H? Yasmin, can you say? H is what? H is height.
Heat.
Height is height is distance. So it will be L, length. Am I right? Raised to power C. You got it? See, mgh, mass into acceleration due to gravity into h, right? So this will be, I can say, m raised to power a, l raised to power b plus c, t raised to power minus 2b. Am I right? Any doubt? Anybody has any doubt? L raised to power b plus c, L raised to, fine, fine. So now I equate the dimensions. Equating dimensions on both sides, equating dimensions. So what will I get? M is 1. Anybody can tell the equations? M is 1 is equal to A. So I got A is equal to 1. Second, 2 is equal to, Jasmine, can you tell? Can you equate the equation dimensions of length?
Minus 2.
Y minus 2. See, you just equate the dimensions of length on both sides.
B plus C. B plus
Correct.
C.
So it will be B plus C. And third one, minus 2 will be equal to equate
Minus
B.
2B.
Correct. It will be minus 2 is equal to minus 2B. So from here, I will get B is equal to 1. When B is equal to 1, so from here, I will get C is equal to 2 minus 1 is equal to 1. So you see, you got A is equal to B is equal to C is equal to 1. From that, you will get the formula potential energy is equal to some constant K into m raised to power 1, g raised to power 1, h raised to power 1. See that? So beautiful. Potential energy is equal to K m g h. Okay. Here you can't say that K is 1. You can't say. You have to write K. You don't know how K is 1. But later on, it was found. Now I'm telling you, I'm not saying according to this question, I'm just telling you for your knowledge sake. Later on, it was found that the unit of mass, G, H, and joule were taken in such a way that K came as 1, right, with corresponding units, whatever it is. So potential energy finally was derived as mgh. बट ये आपको करने की जरूरत नहीं है, ये यहाँ से आपको करने की जरूरत नहीं है. आप इतना करें, you will get full marks. So students, did you enjoy it? Potential energy we got as K M G H. So similarly, students, as a homework, you can derive this also. Kinetic energy is equal to half mv. In fact, you can derive any formula now if you know the principle of dimensional homogeneity. So was it interesting, Arjinder and Jasmine?
Yes, sir.
All right, then we request you to subscribe to our channel, YouTube channel Learn CBSE. Okay, do share and do subscribe. Share with your friends. I wish you all the best. Students, I have one request to you that tomorrow 11 o'clock sharp. Hello, are you listening to me?
Yes, sir.
Yes.
Tomorrow 11 o'clock sharp, I would go live on my channel, that is on YouTube. ठीक है, at 11 a.m. So you know the channel. I think you'll get the notification. So we'll conduct this lecture in live manner. So there are students from other schools also, they want to join. So fine, when as and when they want to join, they can join. Fine. So tomorrow will be live session at 11 a.m. Wish you all the best. Bye.